All right, so let's look at graphing transformations, using transformations to graph radical functions. Remember a square root function, the parent square root function. I'm going to graph it here too. The square root, second x squared. Oops, yeah. The square root function is just a curve. It's just like this, okay? And so what's different about this and this first one here? Plus 2 minus 1 plus 2 means it's going to shift it left 2 and down 1. So down 1 because of that, left 2 because of that. Because anytime you add to the x, it's left. Subtract from the x, it's right. Add the end, it's up. Subtract from the end, it's down. So the original function is going to kind of look like this. It's going to look like a curve like this. So I'm going to do the original. So I need to take this left 2 and down 1. And so it's going to look like this. Okay. You could see this graphically as well. If you want to do the square root of x plus 2 minus 1, you could see, I didn't mean to do that. I'm sorry. That's that. I meant to do the parent function on there too. Let me put that on there. So you could have it to compare to. So you could see that. So there's the blue one. Now, domain and range. How far left will this one go? Well, it will start at -2. How far right will it go? Well, it'll go forever. So it'll be infinity. Range, how far down will it go? Will go down to -1. How far up will it go? Well, it'll go up to infinity. So there's your domain and range. Okay. Now let's look at the next one. Now, this is tricky because on this one, anytime you have a negative to the x, you have to factor that negative out. Factor it out. But I'm going to do it inside the square root. So I'm going to factor out negative. So I got to take it out of this and this. So it'd be x plus 2. This is kind of gross, I know. So transformations, anytime you do a negative to the x part directly, that's a horizontal flip. It's a flip left, right, horizontal flip. Okay, because horizontal is anytime you do it to the x, so you're going to do a horizontal flip, and this would be across the y-axis, and then you're going to go left 2. Okay, and so we'll look at this here. So I'm going to do negative x. I'll show you this. -2. So graph. Notice it flips horizontally, and you go left 2. Okay, so you go left. So flips horizontally. So there's the original. So it flips horizontally. So it flips this way. And then it's going left 2 spots too because of that. So that's why it's going to look like that. So feel free to kind of you can use Desmos, use your calculator to kind of help you with this if you need it. Okay, so domain, how far left is this going to go? Well, this can go forever left. So it's going to be negative infinity. How far right will it go? Well, it'll go to -2. Range, how far down will it go? Well, it'll go down to 0. How far up will it go? Well, it'll go up forever to infinity. So 0 to infinity. All right, now we're going to look at the cube root function. Okay, we'll clear this out. The cube root function, you can see it up there. I'll do it in the calculator. Go to math 4 for this. The cube root of x. Okay, it goes as domain from negative infinity to positive infinity, as you can see. Why is that? Because you can have negative numbers inside of a cube root, because a negative times a negative times a negative can give you a negative, okay? So let's look at the transformations here. -3 means right 3, so it shifts right 3 and up 2. I don't draw these very well, so right 3 and up 2. So here's the original. So you're going to go right 3, up 2, and so it's going to be kind of like this. Whoops, I don't need to do that. So it'd be like that. That's a rough sketch there. Okay, let's see the calculator. I'm using the calculator so you don't have to put up with my bad sketches. So you're going to see this, though. Don't worry about being perfect. Right 3, up 2. Okay, calculator will do it. That was a little too steep when I drew it, I think. Okay. I don't draw those very well, as I said. Now, how far left will this go? Well, this will go forever left. How far right will it go? It'll go forever right. How far down will it go? It'll go forever down. It'll take it forever to get there, but it'll get there eventually. How far up will it go? It'll go up forever. It'll take forever to get there. So domain and range on these are negative infinity to positive infinity. Okay, and so that's something you're going to see. Now, E's got the goofy thing like, I didn't mean to change. That should be H. H has got the goofy thing like D, whenever you have a negative to the X, you're going to have to factor out that negative. It'd be X minus 2, because when you take out a negative out of that, it makes that negative. You're basically dividing that by a negative. So this is going to be a horizontal flip across the y-axis. And then it's going to go right 2, up 2. So instead of going like this, when I flip this around, it's going to go like that. So it's going to go like this, but it's going to go right 2 and up 2. So, and it's going to kind of be, as I said, instead of going like this, it's going to go like this. Okay. You could look at that if you want. We have negative X plus 2 graph. So let's see the original. Sorry, you can't see that. I need to do a better job on this. Okay. So you see it does, it flips it around and you go right 2, up 2. So domain, how far left will this go? It'll go forever to the left. How far right will this go? So your domain and range is going to be consistent here. How far down will it go? It'll go forever down. How far up will it go? It'll go forever up. So you're going to have the same domain and range for all these.